Hello everyone, it is Algebra for Faith and today's lesson is for April 28th, which is 10.3, factoring trinomials from a form where you've got something with the x squared or where you have something with that first term of that trinomial. That's what today's lesson's about. If you are one of the good ones who are watching this, can you please tell other people in your class, especially if they're calling and hitting you up for information because they can't figure out what they're doing, that they need to watch the videos. That's when we explain stuff, because I think a lot of you guys are trying to figure it out from your book, as evidenced from some of the grades I'm getting. And you've got some resources on YouTube. Pretty much everybody can hopefully figure out where YouTube's at. But let's start trying to figure out how to factor trinomials when you have a form of ax squared plus bx plus cx or plus c, which is very similar to what we did yesterday, except as you notice, you have a coefficient with x squared, which is the very first term of that trinomial. And now we're going to break that down and try to figure it out. First of all, we're going to do a lesson opener just to see if you can figure this out from what we did yesterday. Remember, this is there's a lot more thinking involved with this. It's like solving a puzzle or solving a riddle. And I know some of us are not that good at it, but this is kind of what we have to do. So let's look at some lesson openers. So starting off, we did some things that, all right, there's a super glare. That's just a question mark though. If you can't see it, it's probably a question mark. That's a question mark. All right, so what you're trying to figure out is, if I'm looking at these two binomials, let's say we put them together with FOIL, and we ended up with this trinomial, and I'm trying to figure out what is missing. Well, if my last term, and this is, you might want to start thinking about it like this, if my last term ended up being negative 12, then one term was negative 3, what would I have put there in order to get a negative 12? And you all could probably figure that one out. That one is where you need a 4. I'm going to use this nice blue one so it'll be a little bit different. So that's a 4. Now let's go down here. If I have a binomial right here, two binomials, and I put them together with FOIL and I ended up with that, what would be a term I could put in this one where I would end up with 3x squared? That one's pretty simple. You could probably figure that one out. That would be 3x, right? So we're just trying to think, we multiplied polynomials in chapter 9. Now we're factoring it. It's like we're pulling them apart. So if you can remember, we're just kind of taking them apart. We're doing this backwards. Looking at your next one, we have a trinomial that has been factored out into two binomials. So you can think about this in different ways. So let's look at this one. If we factored it out and I had two binomials, now I've got two binomials, you can kind of think, if my last term is going to be that negative 20, what term would I have to put right there in order to get this negative 20? And that would be a negative 5. There's a reason why we're going over this, okay? Just start getting your brain into sync of how we're doing it. We have a trinomial that's been factored into two binomials over here. I'm looking for my first term. On that first term, what would I need to put here in order to get this 7x squared? And it is a 7x. Okay, because I multiply those two together and I would get the 7x squared. So this is kind of a review over FOIL or review over factoring. Your last one, this middle term. This one's a little more challenging because remember, that was your out. If we were using FOIL, that would be O, that would be outer, that would be I, that would be the inner terms, added together in order to get this in the middle. So you might even have to say, all right, I've got it's factored out right here. What would my outer term and my inner term end up becoming right here? So what would my outer term and my inner term end up becoming? So, and we could start to looking, if we looked right here, if I did my outer, that would be 20x. If I did the inner one, that would be a negative 2x. So this term should become an 18x. So that should be 18 or 18x. I just wrote the x twice. So why are we doing this? So yesterday, when we factored binomials, factor a trinomial, your trinomial did not have a number with the very first x squared. Today's, we're going to stick a number with that. And of course, yesterday you probably got used to saying, all right, if I've got C, then basically what are the factors of C in order for me to be able to get B, right? That's what we did. We looked at, because yesterday's trinomial looked like this. It looked like, let me just erase right here. And we can go look at it a little bit. So yesterday's trinomial looked like this. Oh, fiddle. You ever have one of those days where you're just like, really? That's what yesterday's trinomial looked like. You didn't have a number that was with x squared. So what you could say, what are factors of C that when I added them together, I would end up with that B? Well, today, we put a number with that first x squared. So today, so let me make sure my cord's coming with me. I don't want that example up yet because I don't want it to confuse you. You have this one. Factoring trinomials, for now you have a number with that x squared. So now we have ax squared plus bx plus c. I feel like I'm saying my ABCs on Sesame Street here. But I'm getting rid of this because eventually we'll come over here and do some homework. So let's take a look at it. You could sit there and for days you could start saying, okay, if I can figure out these two and I added this, I'd be able to get this. But there's actually a method to this madness, if you want to quote Hamlet, but there's actually a method that's called the British factoring method, right? So the British factoring method is where you're going to go ahead and multiply A and C together. So you multiply those two together, and then after you've got A and C together, whatever you get from that, if I can find those factors, then I'll find those factors whose sum will be B. So that's just a little bit different. So yesterday you looked at C. What were my factors there to be a sum of B? Now that you've added A to it, you're going to have to say, I'm going to multiply A and C together. Whatever I get from that, whatever I got from that product, I'm going to have to find the factors whose sum will end up being B. Now let's look at example 1, because example 1 gives you an easy one that you can kind of go over step by step. And I've written just a little bit of it up here. And don't worry, we are going to do some questions that look very similar to your test and quiz. If you wanted to start marking stuff for your test and quiz, example 1 is like one on your test and your quiz. That table that's coming down on page 415, circle that. That's kind of what you need to know for your test and your quiz. And there's another rule that in this section that I'll tell you, you have to know verbatim, rule by rule, for your quiz. So let's look at example 1. Example 1 is 3x squared plus 7x plus 2. So what are my rules? From the British factoring method, I'm going to multiply A and C together. Fortunately, that's a single digit. That's not that hard. So 3 times 2 equals 6. Then I'm going to think, what kind of factors of 6 do I need to have in order to get 7, which is B? So what kind of factors do I need of 6 that would add up to be 7? There's only 2 factors that would end up being, and that would be 6 times 1, which would be 6, but that's 6 plus 1. Now what do? I take that 6 plus 1, and I put that in there, because there's more steps, guys, before you think, done. No, there's more steps in this stuff. I'm going to just break it down and say, okay, 3x squared, and I'm breaking my middle factor, this middle term, into these two terms. Now I've got plus 1x and plus 6x. I'm not finished. Remember, what you're trying to figure out when you get here is we're looking for this thing called a common binomial. A common binomial. I still need to factor right here. I'm going to go ahead and just put these into two different things. And now what I'm going to try to do is factor out a common monomial to where in these parentheses I have a common binomial. So I'm looking for a common binomial. So what I'm going to do here is what's a factor that is common between these two? It would be x. When in doubt, x is normally a common binomial. So I'm going to go ahead and take out x there. This would just become 3x. Remember, this is going to become 1. Don't just make it just, laying out there by itself. Go ahead and make that 1. So I'm just trying to make sure I'm doing my part here. That would be 1. What would be common between these two? Well, they're both even. If it's an even number, it's divisible by 2. So let's go ahead and see if we just take the 2 out of both of those. I'm going to take 2 out of the 6. So 2 divided by 6 would be 3x. And I'm going to divide 2 by 2, and that would be a 1. Do you have something here? I'm going to look inside those parentheses. Is this a common binomial? So are they both the same? Common binomial, are they both the same? That's what I'm looking for. If that one's common, then that's one of my factors. I bring that down as one factor. What's my other factor? Oh, it's the x plus 2. That's my other binomial. So now what I've done is we have factored this 3x squared plus 7x plus 2 all the way down to these two binomials that when we put them together with FOIL, and you all can check yourself, I would end up with 3x squared plus 7x plus 2. Now, they might have written, no, they wrote it like that. I was just saying, they may have written it in a little bit different order, but I don't know. So let's go through your chapter. Let me tell you what you need to know. Then what we're going to do, rather than go through every single example over and over, we will start on some of your homework. So if we start with your homework, we start going to page 416, you have 2 more examples there. And they warn you at the top of that page, this is something good to circle just to know for your own knowledge, there's not a question on this, is if the binomials that result from factoring the greatest common factor from each grouping are not identical, then you know you've done something wrong. So if you end up with not a common binomial, chances are you did something wrong. Because remember, I told you this in the last thing, there are no prime trinomials on your quiz. There's only one prime one on your entire test. So chances are you can't go through everything and write prime. That would make nothing right on your quiz. It would make 1 right on your test if that's your plan of action. It's not a good plan. So you have 2 more examples you can look over if you're really confused. At the top of page 417, I really want you to circle this right at the top because this is a verbatim quiz question. Quiz question. At the top of page 417, for people who probably don't watch this, I can tell because you'll get it wrong. So remember, what's the first step? They ask you, what is the first step in factoring a polynomial? And that's to check to see if you can factor out a common monomial first. That's what you do in example 4, as well as example 5. They are factoring out some common monomials if you can. Do that first. So turning on over, if you go to page 418, if you do a lot of factoring after a while, that's what they're telling you with example 6. Sometimes you can just see the factors rather than having to do this British method. You might get to where you can just really quickly start to go through and figure out the factors and do it yourself. That's fine. That's using what we did in 10.2. So that's what they're saying, that previous strategy that we used in 10.2 can be modified for this, just to be able to figure out the coefficients of that. With small coefficients, that's efficient. You can do it quicker. But if you got a big coefficient, I'm saying a big number, that's what that means, you're probably going to have to use this British method. Now with this small of a number, you might have been able to figure out, shoot, that's just 6. Let me just figure out some things for 6 rather than doing all this. And you probably could figure that out. So I'm going to start with number 1. The reason why I'm starting with number 1 is because I have this big circle around it in my book that says your number 1 is different from my number 1. So I'm going to do my number 1. And if you start saying, hey, that is different from my number 1, it's probably because it's true. So just warning you that it might be completely different, but hey, let's do that. We're going to do, warn you, I'm going to do 3 from exercise A. I'm going to skip exercise B, it's just more factoring. And then I'm going to do 2 more from exercise B that's like between 17 and 31. We'll do two more from there. I've looked at your test, I've looked at your quiz. You don't have a word problem from that section, so I'm not doing any word problems. If you were going to practice this, I would probably do 1 through 31 odd. Do enough to, like I said, you don't have to turn homework into me. That's another way I can tell that people have not watched the videos, because some of you are turning in homework and it's like, okay, yeah, that tells me something. Or you've not watched it all the way. That's kind of funny. I just wish it was helping you guys on your test. Some of you are not doing anything. All right, so let's look at number 1. Number 1 on page 418, under your exercise A, says to factor. My 1 looks like this. I feel like one of your all's factors is different in your book. And if it is, fine and good, but I'm just trying to basically show you how to do this method using the British factoring method. So what am I supposed to do using the British factoring method? Well, I take A and C, which is 2 and 12, and I multiply those together, and that would become 24. And then I try to look for factors of 24 that would end up, if I added them together, that their sum would be 11. Well, looking at those, you know probably off the top of your head some factors that would be that. If you have to, you can factor it. But you probably know, all right, 2, it could be 1 and 24. It could be 2 times 12. It could be 3 times 8, because 3 plus 8 would be 11. See how you kind of do this? So now you know, but you're not finished. See, right now you think, well, easy breezy, I got this done. And to be honest, if you were doing this in the last section, you were practically done. But you're not done now, sister. You've got to do some more stuff, sisters and brothers. So now I basically have 2 binomials. I'm just going to put these together. And if I can't figure out anything common, in these first 2, I at least got an X going on. But also a 2 and an 8 are even. So divisibility rules tell me if they're even, they're divisible by 2. So basically there is a 2x that is common between those. So if I take the 2x out, if I divide that by 2x, I just have an x left. And if I divide the 8x by 2x, I end up with a 4. Remember, what am I looking for? I am looking for common binomials here. Common binomials. So let's go on over here. Now this is one, they kind of keep it a plus until you get everything out, and then we're going to factor it out. here, but if that's confusing, you don't have to. I don't have an x common, so you're not going to bring an x out here. What is common, what is something that I can divide both of those numbers by, is that 3. So I'm taking the 3, or factoring the 3 out. 3x divided by 3 would just be an x. That 12 divided by 3 would be a 4. Do I have a common binomial? A common binomial. X plus 4, x plus 4. So now I'm just going to bring down the x plus 4 one time because it's common. What's my other binomial? It's this 2x, and it's the plus 3. So that is how you factor this trinomial all the way down to 2 binomials. Now I'm going to move from that to what number did I say we were going to do? Let's go ahead and do 5. Because that's what I put down, is that I'll do that, I'll do 5. You have these, this is common in, oh fiddle, I don't have it written up right there. So let's look at number 5. Number 5 is 3x squared plus 5x minus 28. And if we're doing that like we have been saying, using the British factoring method, then I am going to multiply 3 times the negative 8. So 3 times the negative 8, that's A and C, are going to end up becoming a negative 84. Remember, I'm going to look for factors of that would end up adding together to become what B is, which is 5. So what are factors of 84, if I added them together, would end up becoming 5. And guys, you do this however you need to, or whatever you want to do, but you might want to just start breaking it down into prime factoring. You got 1 and 84, that's not going to work. You could divide it by 2. If you divided it by 2, that wouldn't work, because that would end up being like 42. You could try 3, you could go on up. Remember, you use basically your prime numbers. The prime number that you're using here to get it divided down to, which you would pick up on if you do the prime factoring, is 7. Because 7 times 12 will be 84. Those are the 2 factors you're looking for. And if I add those together, well, technically one of them is going to be negative, right? Then I could get a 5 from that if I subtract 7 from 12. Because remember, yes, it's the sum, but it's going to be a negative 7 to a positive 12, because that's what my number there is, positive. So 12 is going to have to be positive. So let's go ahead and write that out the way we think it is going to be. So I think what this is going to have to be is I'm going to have a positive 12x, and then I'm going to subtract a negative 5x, right? I'm trying to make sure, not 5x. Where did I get 5x? 7x. I thought that is not right. 7x. And that's going to end up becoming a negative 28, right? We've still got negative 28. That's my C that's hanging out up here. I'm going to go ahead and separate that. I'm going to factor out common monomials from both of those. If nothing else, over here I at least got x going on. What am I going to look for as I'm factoring these out? I want to see if I get 2 parentheses that have the same thing in it. That's what we did over here. We had 2 parentheses that had the same thing. That's what I'm looking for. I'm going to factor out 3 and x because 12 is divisible by 3. So I'm factoring out 3x, which means 3x squared divided by 3x is just going to be a plain old x. 12x divided by 3x is going to end up just being a plain old 4. Let me do the same thing over here. I am going to take out not 7x because x isn't common, but is 28 divisible by 7? because if it's not, I'm in trouble. Yeah, 28 is divisible by 7. So I'm going to take out the 7. 7x divided by 7 is just going to be plain old x. 28 divided by 7 is going to end up being, I'm just going to put a plus here so we don't get confused. It's going to end up being a negative 4, right? So yeah, because I should have put that down to, what's that? Yeah, it'll be a hot, no. I messed that up. We're going to keep that negative. Negative 7 divided by negative 28 is going to end up being a positive 4. There we go. I thought I needed to make that plus, and I didn't. I had it right the first time. Do we have a common binomial? A common binomial. Is the stuff in my parentheses the same? If it is, then I'm on the right track. That's going to be one of my binomials. That's going to be x plus 4. I just write it down one time. My other binomial will be the 3x minus 7. That's me factoring this all the way down to here. We're going to do that one more time. The other two we're going to do is where we have to factor out a common monomial first. So the next one I chose is going to be, there went a marker. The next one I chose is going to be 9. So number 9 is going to be 15c squared plus 19c. Remember I think they're throwing you off here because they're using c's instead of x's. Don't worry about it. It's still the same pattern is what we're looking at. So a and c added together. That would be the 15 multiplied to the 6. The 15 multiplied to the 6 is going to be 90. 15 times 6 is going to be 90. I'm going to look for factors from that that's going to equal b, which is b would be 19. Factors of 90 that would end up, if I added them together, would be 19. A factor of 90, I feel like this is one for you all might say, I think I've got this one. I don't have to go over here and try to divide it by 7 and kill myself. I can figure this one out. So what would be the factors that would end up being 90? How about 9 times 10? Because those two, if I add them together, would be 19. Let's go ahead and fill that out. So we've got 15c squared. I'm trying to see which one did they put first so I can just make sure. Yeah, they put a 9 down. Plus 9c plus 10c. And then we still have the plus 6 up there. So what I did is I took those two factors, I just broke that up and put that into the middle right here. Now I'm going to divide this up into two binomials. Factor out common monomials from each of those two binomials. So let's do this right here. So what would be for 15, other than the c's, is there something that I could divide both the 15 and the 9 by? 3. Let's divide both of those by 3c. So 15 divided by 3c would end up becoming, right? 15 would be a 5c. I keep looking at the wrong one. Yeah, 5c. 9c divided by 3c would end up just being 3. 10 and 6. 10 and 6. Those are even numbers. If nothing else, it's divisible by 2. So let me divide 10 by 2. That's going to end up being a 5c. 6 by 2. That would end up being a 3. Do I have a common binomial? Is what's in my parentheses, are those common? Are they the same? They are. So I'm just going to take one of those down. Not both of them, only one. I'm factoring that out. One of those common factors is 5c plus 3. What's my other factor? The 3c plus 2. We've done that so far. Now, are you ready for fun? Or are you ready for fun? All right, we're going to do 17 next. Let me make sure. I think I'll just stay on this side. I won't erase that one. My screensaver is going back. So let's go over here to 17C. 17C, just 17, whatever. I'm going to erase this too so it doesn't get in the way and totally confuse us. So 17 is 6x squared plus 3x minus 30. 17, 6x squared plus 3x minus 30. This is where we're using that rule. I told you to circle because it's just a common question on one of your tests. That's right there at the top of page 4. Where is it at? On the top of page 417. Remember, the first step in factoring a polynomial is to check to see whether you can factor out a common monomial. So the first step in factoring this, before I start saying A times C equals, is it B? All right, I need to factor this thing out. So look, I've got 6x, 3x, and 30. What is common? Looking at just the numbers, because the letters aren't going to work. Looking at just the numbers, can I divide each of those numbers by something and bring it all the way down to something prime, to something smaller? And there should be something screaming to you in 17 that I could factor out, and that would be 3. So if I divide 6 by 3, I've got 2x squared. If I divide the 3x by 3, I just have an x. And finally, if I divide out 30 by 3, I have 10. So what you're going to have to remember with this one is you can't forget this 3. This 3 is going to follow us all the way through stuff now. All right, so now that I've got it broken down to that, I can use my British factoring method by saying A times C, which equals 20. What would be 2 factors there of 20 that would equal B, and that B is a 1. Because remember, there's not anything right there, but technically it's 1. And if once you figure that out, looking at the factors of 20 I could add together and it would be that. Factors of 20. Factors of 20 would be like 20 times 1. So, right? We're looking, actually that would not work. I was thinking of something else. I was thinking of 19 for some reason. So what would be factors of 20? So 20 times 1, not going to work. 2 times 10, not going to work. So is there any factors of 20 that if I added them or subtracted them together, I'd just get 1? How about 4 and 5? 4 and 5, right? So now you have to figure out which of those numbers do I have to have positive in order to get that positive 1. And that should, that's something from 10.2 as well that we've worked on. So let's go ahead and start writing this out. So we have got 2 numbers. I'm going to bring down my 3. I have 2x squared. Then I'm going to have a negative 4x, a positive 5x in order to get that positive 1. And then I still have the 10. And this is where you might want to start brackety bracks, big brackets, and little parentheses. So just so you can kind of figure out what's happening. So I'm going to divide that into 2 binomials and then factor out. So that's why I said I'm going to do big brackets, and then I'm going to write inside 2x squared, right? I'm going to try to factor out these 2. So just to show you what I'm looking, I'm going to divide up these 2, right? And then I'm going to put it in this big bracket so you can see what we're doing. So looking at these, I definitely have a common x, but what else do I have common between those? I have a 2. So 2x squared divided by 2x would just be x. Now I'm starting to look for a common binomial. The minus 4x divided by 2x would end up being just a 2. So I've got x minus 2, right? Same thing over here. Going to, what would be something common between those two numbers, or what number would be divisible? It's going to be that 5. 5x divided by 5 is just going to be an x. 10 divided, that negative 10 divided by the 5 is going to become 2. That's why I was starting to do those big brackets. So in here, 3 is still coming down, guys. 3 still has to just move down. Don't forget 3. If there's going to be a place where you're going to make a mistake, it's going to be right there, leaving out that 3. Now I have a common binomial. I have a common binomial. So, and that's going to be x minus 2. But I also have another binomial, 2x plus 5. 2x plus 5. The 3 stays right here in front. All right, so the 3 is still going to hang out right here in the front of that. That's how you factor that all the way down. So let's do one more like that, just to get it into your brain. One more. That's going to be 19. I think that's what I did. Let me look at which ones I circled. No, I did not. I circled 31 because I had a feeling that 31 might be the one you all look at and think, oh, that's the last one, and so it might be harder. So 31 looks like 2x squared minus 18xy minus 104y squared, right? And this is one where when you start to look at it, you start to think, there's too many letters. But that's okay. What we're just going to do is treat those letters like numbers and just not worry about it. But right off the bat, you can say, all right, 2, 18, 104. Those are all even numbers. So what would be common between all of them? Obviously, the 2, because it's the smallest one. So the first thing I'm going to do is factor out the 2 from each one. This simply becomes an x squared. That's going to become 9xy. And then the 104, when I divide that, hold on, I was just checking my math, that would be 52y squared, right? Then I'm going to do the same thing like we've been doing. This number right in front, what would A and C be? So if I multiplied the A and the C, it would end up becoming, that's a 1, guys, and that's the 52. It would just end up being a negative 52. And I'm looking for factors of it that would end up being a negative 9. So factors of a negative 52 that would end up becoming a negative 9. So what would factors of that, of 52 be? And you could start going through all those different factors. This is one where, once again, they're using a weird prime number for you just to kind of throw you off. Because remember, you start going, you divide it by 2, you divide it by 3, you divide it by 7, you do all these things. This one's going to be a 13. Yeah, I know, it's weird. But there's going to be one, a factor with 13, where if I subtracted it, I would end up with the negative 9, which means your 13 is going to have to end up being negative. So 4 and 13. 4 and 13. And as I write that out together, remember my 2 is going to stay here. I have x squared and plus 4, plus 4xy. And then I have the negative 13xy. And then finally, I have negative 52y squared. So we've got all that written out. I'm just checking my book to make sure I have that all written. Now I'm going to carry down my 2, but then I'm going to look and I'm going to make these into 2 binomials. And what I'm looking for is, can I find a common, 2 common binomials there that I can factor out? I'm looking for 2 common binomials. 2 keeps on coming down. So what would be common between those 2? And you're kind of thinking, what? What do you mean? What's common between those two? It's the x. I'm going to pull out the x. So x squared divided by x is just x. 4xy divided by x is just going to be 4y. Then I'm going to come to this one. It's going to be negative. So, just realize that what I'm going to be factoring out is going to be negative. All right, we figured out up here that 13 is a factor of 52. So I can factor out 13, but what else is common in 13 with these two? Oh, it's the y. So go ahead and factor out the 13y. 13xy divided by 13y is simply going to become x. The negative 52y squared divided by that 13y is going to end up becoming a positive 4y. And then I'll look into that bracket. I keep bringing down the 2, keep bringing down the 2. I have a common binomial, so I'm going to bring that down one time. The x plus 4y, I bring that down. What's my other binomial? It's the x minus 13y. So guys, some of you are probably already starting to cross your eyes saying this is difficult and hard, and just calm down. It's multiplication tables, it's division tables, and then it's just some tedious work. That's all. It's just tedium. What's my main objective for this whole little section? Finding common binomials that I can factor out one of those and then just have my remaining binomial left. That's what we did here. The last two problems is where we factored out a common monomial from all of them before we factored and got down to our common binomials and ended up with this. So yes, it's like taking last chapter and doing everything backwards to it, so or however you want to get it into your brain. So that's all for today's lesson. Today was April 28th. Have good time with this. If you've got any questions, please text me. Let me know something. Don't just send in quizzes doing something wrong. Before you say, well, it's not really going to affect my grade and everything. Guys, you got math for at least 3 more years. You all are freshmen. You've got 3 more years of math before you can simply get out of high school. So you should go ahead and start getting this in your brain. Plus, you have to take the ACT now in order to graduate according to the state of Tennessee's rules. So yes, this stuff is on there too. So good luck. If you have any questions, text me, leave a comment. Hopefully I'll notice. But the easiest way is to text me and let me get in touch with you. Have a great day. And I don't think we said a prayer before we started this. No wonder we're so crazy. Let's go ahead and say a quick word of prayer to the Lord. Heavenly Father, thank you for giving us insight in your world of mathematics. And Father, we just praise you and thank you for everything you've given us, and be with us and go with us throughout this day. We love you in Jesus' name. Amen. Have a great day, guys.